are going to introduce our first speaker of the day from here in Stockholm. As Annika mentioned, it's Theo Agelopoulos, and he is going to be focusing on project lifestyle management in the construction and infrastructure industries. Why it's so important, what we can learn from experiments and projects that have already been a success, and what can be done to support a better BIM process. So please give him a very warm welcome to the stage, Theo Agelopoulos.
Great, thank you so much. It's great to be here, and hello to the people online and in Oslo. So, as you know, I lead Autodesk AEC design strategy. So what I thought I would do today is kind of take you a little bit through a journey. So I look forward to some of the questions at the end. Okay, I'm going to start with our safe harbor statement, which is don't buy and sell stock from Autodesk as a result of what I say today. None of us want to go to jail. So one of the things I really wanted to start with is the world looks very different today than it did 5 years ago. And certainly at Autodesk, and I think a lot of companies, we always look at what's happening in the marketplace, what's really driving demand, how has work changed, and then what are some of the technology trends that are happening that are influencing our industry. And when we put them all together, that's kind of how we make some of the decisions we make, at least from a technology perspective. But the underlying theme, I would say, is that digital transformation is really driving a huge change in the industry. And things like COVID, all it really did was really accelerate the digital transformation journey that we've been on. So for myself, as an example, not that I want to date myself, but since I entered the workforce almost 30 years ago, we were already beginning that digital transformation. What's interesting is, for many of us that have been in the technology side of the industry over the last 30 years, is that even though we started digitally transforming 40 years ago, the industry hasn't really been driving a lot of productivity output relative to other industries. So you can see here, this is an interesting chart on the left-hand side that shows how does the construction industry compared to other industries from a relative productivity perspective. And you can see it's been relatively flat. On the right-hand side, it actually kind of breaks down the industry between civil engineering, architecture, building engineering, and so forth. So the key takeaway from this slide is, and this is actually from one of the UK agencies that put out this more recently, is that we've been relatively flat. And actually, McKinsey did an interesting study several years ago, and I believe that the construction output of our industry was right behind agriculture. I think it ranked like number 24 or 25. So a lot of work to be done. The other interesting statistic is, if you think about a lot of the information that we generate during the planning and engineering and construction phase, 95% of that data goes unused. So we create lots and lots of data, but we haven't really optimized the way we seamlessly use that data all the way through the asset lifecycle. So I'm going to kind of share with you, like I said, I'm going to take you a little bit on a journey of how we certainly look about the evolution of digital transformation. So as I mentioned earlier, I'm not that old, but when I first came into the workforce, we'd already transitioned from drawing boards to computers. So one of my first jobs coming out of school was I worked at the Navy shipyards, and we were building a AutoCAD model of a Navy frigate. So that was my first job, and based on that AutoCAD model, we were running things like finite element analysis and doing something other interesting. But the computing power of 30 years ago versus the computing power today, it's not even close. My iPhone has more computing power than the PC or the Unix box that I was using when I first entered the workforce. So that was kind of entering that CAD phase. About 15 years ago, we started seeing the evolution of building information modeling. And then the last 4 to 5 years, building information modeling got a little bit of a shot in the arm with the introduction of the cloud. So let me kind of make a profound statement today and say, building information modeling is really the foundation of digital transformation. So when we think about what building information modeling is today versus what it was 15 years ago, it's different. So 15 years ago, the word building was really a noun. The word building today is really a verb. Building information modeling is not a product. Just because you buy technology from Autodesk or other companies, it doesn't necessarily mean that you're doing building information modeling. Building information modeling is really a digital delivery process the technology that certainly companies like Autodesk build enables that process to happen. So, again, I'm going to say it again, building information modeling is not a product. Building information modeling is a process. You all are implementing digital delivery processes that are based on BIM, and certainly companies like Autodesk and other technology companies deliver technology to enable that to happen. So if we do our job, and the latest buzzword in our industry has been digital twins, but I'll say if we do our job, a digital twin really should be the derivative of a building information modeling process. Again, so if we do our job and we implement digital processes, we eliminate loss of data through the complete asset lifecycle, what you should end up with at the end of that is a digital twin. And when everyone starts delivering digital twins, owners, whether they're public or private owners, will begin to assemble these digital twins into a connected ecosystem, resulting in things like smart cities and smart infrastructure and smart buildings and smart campuses and all the other things that ultimately drive a digital process. So, many of us, talk about, moving from CAD to BIM. I would kind of say that I think where we are in our industry, it's about CAD and BIM. It's not about CAD or BIM. Even those people doing BIM are still producing CAD deliverables. In some cases, it's the output of the BIM process, but in many cases, you still need to use CAD. Not everything has to be a 3D model. So what's interesting, even CAD has evolved. So if you think about AutoCAD, a product that Autodesk developed 40 years ago, which I still walk into rooms and people say the AutoCAD company's here, not Autodesk, which is always fun. You can see that we're still investing in products like AutoCAD, and we're even introducing things like AI and machine learning to make it easier for people to use our products, to get better insights out of their CAD drawings. Good examples, if many of you use Outlook, and when you type an email, and you'll see that it kind of predicts what you're going to type. We're starting to do some of those same things inside of AutoCAD, where it will actually predict, what the next command should be. The other thing we've seen with the evolution of cloud computing is we're now pushing the idea of having a lightweight version of AutoCAD in the web as well. So depending on who you are and what you do, you may use even a different type of CAD. So if I'm an executive, I really don't need AutoCAD. All I want to do is review CAD files. I can simply bring up a web browser, and the way that I interact with that information is much simpler than what a traditional professional user would do. The next phase is where most of us are spending, I would say, our time and kind of the foundation of what this conference is. And I heard some great discussions yesterday and some great speeches. And I think many of you are trying to drive disruption, continued disruption in the industry. Things like sustainability are really driving the way, kind of an acceleration of BIM as well. We're seeing government mandates are also influencing the type of work that's happening. So a bigger push towards infrastructure. But I did want to spend a little bit of time and talk about what does that mean today? We're still investing, and certainly companies like Autodesk continue to invest in BIM authoring. So this is a great example of our Civil 3D, and we are continuing to drive innovation in our existing products, the ability to model roads and highways and produce 3D models that kind of drive the BIM process. We're even investing in, especially in Europe, where things like ISO 19650 and IFC has become the mechanism and the way that you exchange information between different vendor applications. So regardless of whether it's a building, regardless whether it's a bridge, a piece of road and highway, a tunnel, the mechanism that we're starting to see is more open, interoperable formats to allow people to use multiple products. And we certainly don't think that everyone just uses Autodesk. The reality is, as much as I'd love you just to use Autodesk, you're using a multitude of different applications. So as a technology company, we need to make sure that we enable that seamless movement of data. We're starting to see real changes in the way things like bridges are being designed. So we're moving away from starting with just an analytical model of a civil structure and beginning with parametric modeling and then driving a connection from parametric models into analysis and simulation to drive a better outcome, a more sustainable outcome, a more optimal outcome. So you'll hear me kind of talk about the word outcome-based. We're even seeing, and the reason I'm showing you this is probably the number one most requested ad to Revit. So every time I come to the Nordics, pre-COVID, I would come at least a couple times a year. The number one thing I would always get asked is, when are you going to add site design for landscape architects. So now we have site design inside of Revit. So you have a unified experience if you're an architect or a landscape architect doing design. What's interesting, as I talked earlier about the need to eliminate barriers of moving data between applications, both Autodesk applications and third-party applications, that same terrain model can be used by other Autodesk applications, and it can also be exported with IFC as well. And then, Autodesk made its biggest acquisition a year ago. One of the big pushes we made was into the water sector. So we even now have, and we're seeing more innovation around things like, water hydraulic analysis, asset management, operational analytics of plants. So this is just an example of some of the continuing investments, not just in buildings, but I would say over the last several years, we've seen an acceleration. And I think one of the slides I saw yesterday showed infrastructure lagging behind the building market, and I think you've seen very much an acceleration in the infrastructure market as a result. And we can do things, things like urban flooding, storm sewer flood analysis. These are all, highly, I would say, complicated analysis and simulation that we're trying to make easy to implement into the products. Okay, so something like this shouldn't take a PhD to run. It should be relatively commercial and off the shelf. It should provide great insights, and it should allow you ultimately to make better decisions earlier in the BIM process. And as many of you know, the whole value proposition of BIM is that if you make good decisions early, you drive less bad decisions later, which is where most of the risk is. So if I can make a mistake at my computer, and I can correct that mistake in my computer, it's a lot less costly than doing it in the field, okay? Which is actually one of the major reasons why you see, especially mega projects, having major cost overruns. And then, from how do we connect, BIM from design to construction, virtual design and construction? I don't want to say it's become the norm. I definitely see countries and markets like the Nordics being very progressive and further ahead than other markets around the world in the adoption of models in virtual design and construction. And again, that kind of drives the ability to do clash detection, the ability to do time sequencing, the ability to connect that, to build constructible models, and basically take a design model, deconstruct it, apply construction means and methods, and then use it as a constructible model. And that's why many of the construction companies that are in the room today or in Oslo or online are hiring architects and engineers to be able to do this kind of work. So the profile of what an engineering company hires and the profile of what a construction company hires looks very different today than it did when I certainly entered the workforce. And I think we're going to continue to see that as we go forward. Some of the other things I mentioned was, technology companies need to drive, interoperability, and the way we're going to drive interoperability is to form partnerships with other companies that have a common goal. So whether it's Autodesk partnering, in this case, with, you'll see on the slide, Esri, or a company called Oris out of France, or we have certainly entered into interoperability agreements with companies like Bentley and Trimble and Hexagon and others, and we'll continue to do that. And I think the industry continues to do that, not just through things like Building Smart, but also through peer-to-peer engagements. One of the things I wanted to share with you, Esri is one of the largest geospatial providers in the world. One of the biggest asks we certainly have is how do we bring BIM and geospatial information together? How do we create a better context of the real world to drive better outcomes, higher quality designs, more optimal designs, and ultimately how do we take that BIM information modeling and put it back into geo? So we've been spending a lot of time at Autodesk with Esri doing direct integration. So today, what you can do today out of the box, quite frankly, is whether you connect Autodesk technology like Civil 3D or Map 3D, you can connect it to ArcGIS and you can seamlessly bring that data in to create your context model for design. You can actually connect our products to the Esri cloud, and you can also now connect the Autodesk cloud or our BIM environment in the cloud to the Esri GIS environment in the cloud. So what we're starting to see this emergence of federated data systems. Okay, and what I mean by federated data systems is many of our customers, they're using different vendor applications to do things like financials, human resources, BIM, CAD, GIS, and what they're really trying to do is connect these into a seamless enterprise data environment. And we're starting to see examples where companies are building their own data lakes, and on top of that, they're building their own applications, to do certain things that they're interested in. So this is a great example, and the reason I'm sharing it, of how you can create an enterprise data environment between an Autodesk environment and an Esri environment, and you'll see in the video there the idea of having kind of this, ArcGIS, Autodesk Construction Cloud seamlessly connected in a cloud-based environment, and customers, and we're seeing a lot of public sector customers trying to build a unique experience on top of existing commercial off-the-shelf technologies. I'm probably going to skip that. The other thing that we talked a lot about yesterday, and I'm sure there'll be lots of discussion today, is really around sustainability. I think what's different today than several years ago is we're starting to see governments and agencies really begin to mandate the reduction in carbon. And in the US, I'll give as an example, many building owners and buildings generate about 40% of carbon in the world. As a result of their Securities and Exchange Commission filings, have to report on their carbon. So now that's forcing building owners to actually have to begin the process by doing a lot of analysis and simulation to drive a reduced carbon footprint. So this is an example where there's a company in France called Oris. They've built a materials intelligence platform, and we're even now connecting our technologies like Civil 3D to provide better, more sustainable outcomes in infrastructure and roads and highways. So you're going to start seeing more and more, and I think One Click presented yesterday as well when I was on the panel. There's lots of, I would say, investment in those types of sustainability solutions that will ultimately drive our industry to become more sustainable, reduce carbon, higher quality, etc. And then this is just a video that shows, as a user, I can seamlessly connect to a third-party sustainability analysis solution, continue to do my work the same way that I was, but now I can actually optimize my decision-making, as I said earlier, in the digital delivery process. So I would say today, and the reason I'm showing you this project is I actually visited, this is from Norconsult, and this project's about, I think it started 5 years ago. But what you're starting to see is those companies that are adopting building information modeling driving very tangible benefits. So as you can see, in this particular case, they increased their digital delivery speed by 70% on the E39 projects, which is one of the largest road and highway projects in the Nordics. We're seeing examples in rail. So this is an example in China, and as you can see, there's actual, real money connected to, the benefits of doing things like clash detection. We're seeing airports as one of the most progressive adopters of building information modeling. The reason I like airports, aside from the fact I'm always at an airport, is the fact that an airport is like a mini city. You've got underground utilities, you've got runways, you've got vertical infrastructure, you've got buildings, and all of that comes together in a connected ecosystem. And when we think about the foundation and the future, what does that look like? And you're starting to hear the term more and more around things like smart cities. A smart airport is essentially a smart mini city. So these are, a lot of the airports around the world are really driving, I would say, at the tip of the spear of driving towards the concept of things like smart cities. And outside of airports and roads and highways and rail and transit, we're also seeing examples in the water industry, things around optimization, around the ability to deliver a water wastewater treatment plant. The ability to do things like, and for those of you many years ago that remember New Orleans, actually Autodesk University was at New Orleans last year, and that city is still recovering, but the ability to remodel how cities will flood and simulate that and build more resilient and redundant more resilient and better ways to recover from those kinds of natural disasters is becoming more commonplace. And again, this is just another example of a smart canal from Scottish Water. So lots of really good, exciting, I would say, innovative examples of how the industry and certainly our customers are using building information modeling to deliver better projects. And we're at the point, I would say, where it's not just about buildings, it's about infrastructure, it's transportation, it's water, it's industrial environments. All of them are benefiting from the ability of adopting digital building information modeling and digital delivery. I mentioned, earlier that, BIM kind of got a shot in the arm. It was like supercharged when cloud computing, or the cost of cloud computing came down. So when you combined BIM and cloud, then we started to get even more benefits. So when we certainly think about digital delivery, and I mentioned earlier that 95% of the data that gets created goes unused, there's these artificial barriers between different stakeholders and different phases of the asset lifecycle. And ideally, and this is, I would say, a very simplified view of what really is happening, but the idea is that when you're in design, there's a common data environment and you're really doing more design management. But within that common data environment of design, there's also multiple common data environments. So if you're using Autodesk and you're using another provider and you're trying to bring all that data together, you've generally got multiple CDEs, okay? Well, if you think about the concept that I talked about of enabling these federated data environments, if we do our job as technology providers and if we participate in associations like Building Smart, we should be able to create this seamless connection in these federated data environments. But even in construction, when you've got a general contractor and multiple subs, you've also got multiple common data environments. And then you've got the owner who's consuming all that data. And if you think about the total operating cost of an asset, 50 years, 85, even some cases higher, 85% of the total operating cost of that asset is in operations and maintenance. But some of the decisions we make very early on in the project in planning and design can optimize the way that asset operates over the term of its life. So if you really want to get sustainable outcomes, you have to make some of those decisions very early. And that's one of the key reasons why the industry needs to continue to invest in building information modeling. And certainly from an Autodesk perspective, today we build we use the same common data environment between design management and construction management. So if you're an Autodesk customer and you're using BIM Collaborate Pro for doing design collaboration, and you're using Autodesk Build for construction execution, it's all built on the same common data environment. We did that to try and break down some of those barriers between transitioning from design to construction. And then the applications you buy are a function of who you are and what you do. So we're trying to build this integrated, connected, common data environment. And really this is the foundation of what we do. And I'll talk a little bit about our transition from being a product company to a data and platform company. But what I'm showing you today is what you can use and buy today. And as we all move to the cloud, then the number one thing that our clients are really struggling with is data sovereignty. How do I address cloud security, privacy, data location based on the requirements, especially in public sector? And certainly what we're doing at Autodesk is building a kind of a federated data environment. We have data centers now in Dublin to service the EU. We have data centers in the US. We're building new data centers in new countries this year, in Australia, later on Germany and Japan. And then on top of that, we have to service a lot of the data security requirements of different markets. The UK has UK Cyber Essentials Plus. Germany has C5. There's SOC 2. I mean, the list goes on. So this is going to be a, kind of a common, I think, demand placed on all technology providers is to meet the criteria of a lot of what your clients are demanding today. But once you move into this environment, the great thing is that I've shifted a lot of my design collaboration, my construction management into this cloud environment, and I now have the ability to aggregate lots of different models, track how this project is going, build different types of dashboards to get better insights, and you're starting to kind of expose this data to other stakeholders, not just people that are content creators. So the biggest difference, if you think about it today, is most of the people that have a lot of the insight are the people using Revit or Civil 3D or Plan 3D or one of our competitors' products. But when you shift that information into this common data environment in the cloud, now other stakeholders, executives in your company, non-technical users can begin to get better project insight. And the more connection of data that we create, the more insight we're going to gain, okay? So, and this is just a great example, and the reason I show this is because this is a great example of integrating what I like to call horizontal and vertical BIM. So it shouldn't matter what content creation tool you use to create a model, whether it's an Autodesk product or a third-party application. What you should be able to do is bring it all together in a coordinated way and make better decisions, Okay, so regardless of whether it's a piece of linear infrastructure coming together, and if you think about the example I talked about airports, it shouldn't really matter whether it's a tunnel or a road or a runway or a building or a facility. It should be a unified design and modeling environment that then drives kind of a consistent construction execution environment as well. And that's what we're building, I would say, and that's where the industry needs to head if we're really going to break down some of the silos that I talked about earlier. But we're not done, okay? There's still lots more to do relative to BIM in design. And I think many of you today are watching a lot of phenomenal innovation going on around things like ChatGPT, AI machine learning. I think reality capture's been going on for a while. We're still seeing the ability to apply AI machine learning to reality capture data. So it's a very exciting time for those of you that are in the design sector. So what I wanted to share is kind of how does Autodesk think about the evolution of design? So I talked earlier about, we went from 2D to 3D modeling, and then went from 3D modeling to kind of BIM. But within the environment and the BIM environment where we are today, what I'm defining as traditional design is people generating 3D models, doing different types of analyses. That's what most of you, I would say, in many cases, are already probably doing. And maybe not at the same level of maturity in all your offices or all your countries if you're a multinational, but I'd say all of you are probably doing some of this. The next phase of the design journey is what we're calling computational design. So that's the ability to essentially connect 3D models to different types of automation to optimize repetitive tasks. So in our case, we have a product called Dynamo, which is a scripting tool. The ability to take that scripting tool and automate things that I would consider not low value, but low value to a high value employee. You want to automate and have that high value employee focus on high value tasks. And I'll show you an example. But then we think there's this end state, which is called outcome-based design. So remember that I said, if you want to drive more sustainable outcomes, then you should be thinking about that at the beginning of the process. That's where you make certain decisions about material selection, orientation of a building, what kind of HVAC system you want to put in the building, etc. So how do we use technology to help us make those decisions earlier? So that's what we think about auto outcome-based design. So I'm going to use I'm going to look 10 years forward. What does that look like 10 years from now? So if I'm an engineer, okay, which by chance I am, I'm going to say, hey, I need to move a certain amount of people or products from point A to point B. Okay? If I'm in this federated world where I can get access to geotechnical data that's already around, or flood data, or the cost of steel, the cost of concrete, the labor force, I should be able to press a button and say go from point A to point B, and the computer should be able to go out and optimize for that solution. It should optimize for the best outcome based on my input criteria. So it should decide, hey, this road needs to be above ground, below ground, at grade between point A and point B or C. It should say, hey, the bridge needs to be steel versus concrete because the price of steel is cheaper or it's more available in this market, and I need this kind of foundation system because we have bedrock or we don't have bedrock or whatever. So think of multiple analyses happening concurrently and optimizing some of those engineering decisions or planning decisions you're making. So that's what the future looks like 10 years from now, but I'm going to say that hopefully we're going to get there sooner than that. So this is just an example of people today using products like Revit and Dynamo, and you can see they've built a bunch of scripts, and it's automating the way you're sectioning tunnels, and we're seeing optimizations on some projects, people going from 3 months to 3 weeks, and then taking a lot of these scripts and then applying them as a standard across their company. This is what people are doing today. We're seeing it in Revit. We're seeing it in products like Civil 3D. So this is a great example, someone laying just different furniture, guardrail and so forth, and I think lighting along a road, something that you would manually go along and click. You can create a script and just let it, lay it automatically and automate some of the documentation as well. So again, something you can do today. We're even investing in including things like terrain optimization. So for those of you that are civil engineers and know how boring it is to lay out parking lots, okay, it's not something I aspire to do. which I've done, but the ability to lay out, hey, this is my drainage line, I need to balance, cut and fill, and let the computer optimize for that solution. So this is, everything I'm sharing with you today is kind of a step towards outcome-based design, and it's already available in a lot of our products, and obviously there's other companies that are doing some of the same things as well. And the reason I'm showing you this example is, this is a really cool thing. There's a guy online who used ChatGPT to automatically create auto Lisp code. So he went on ChatGPT and he basically said, hey, create an auto Lisp routine that changes the color of elements. And he went in and he just said, hey, create it. And you can see what he's typing, create auto Lisp. ChatGPT actually went out. It knows enough about AutoCAD and auto Lisp that it essentially went out and created the code. So think about that for a sec. Think about in your company today, there's probably some guy or girl that sits in the corner who's really good at coding and is doing all this kind of automation. But what happens when you make that available to everyone? So as we move to this no-code, low-code environment, you begin to build automation into the existing worlds that you're already operating in. So this is just a very simple example, but this could be Civil 3D, it could be Revit, it could be connecting lots of different things together. I mean, don't think about ChatGPT is just about writing essays for your kids, okay? ChatGPT and the concept of using things like ChatGPT is going to really transform the way we automate and optimize a lot of things we're already trying to do in our industry. So this is just kind of a cool example of that. Hopefully next year I'll have an even better one that I can share with you. Okay, what I mentioned earlier was that vision of 10 years is already starting today. We have to begin building the platform and the foundation for the future of BIM, okay? So many of you may know a company called Spacemaker that we acquired 2 years ago, actually, if you can believe that. And what Spacemaker actually has is an AI machine learning that drives optimum decisions. So in their particular case, they're optimizing spaces on a parcel of land, but the way they're doing that is applying different types of analyses and simulation. So in Spacemaker today, there's over 100 different analyses, but the ability to put those different types of analyses together and let the computer produce a solution is the beginning of what I'm going to say is outcome-based design. So what you're seeing here is an example of a small kind of project, a building, and it's going through and it's applying the different analyses. You can weight these different analyses, and it's producing an optimized mass. Okay, and now I've got, historically as a planner, you would say, hey, I'm going to try 3 or 4 different scenarios. I can only really afford to do 3 or 4 for the owner. The owner gets to pick 1 out of 3. But what about if the computer can generate thousands or millions of different solutions, and then you can pick the best one you want? Okay, so that's what Spacemaker does. And then once you've produced that mass, what you want to be able to do is quickly plug it into your digital delivery design environment. So what you're seeing here is essentially taking a Spacemaker model and pushing it straight into Revit and continuing to allow you to use Revit as your detailed design and documentation tool. So this is what you can already do today. So this is just an example that we're already building a lot of the platform and a lot of the IP to enable the vision that I shared with you a little earlier. Okay, so there's still more. What I kind of share with you is kind of the beginning of what the future of BIM is. And when we think about the future of BIM, is what we're really trying to do is smooth out this curve. Remember at the beginning I said our industry's been pretty flat relative to other industries. We've gotten better, but relative to other industries, we're still pretty flat. That kind of sawtooth diagram at the bottom, which that diagram came out like 20 years ago or 15 years ago, we're a little closer, right? But we're not on the curve that we want. So the BIM, as we know, it has to evolve and it needs to meet the industry's needs. A lot of what you're talking about, over the next couple of days. So we need to move it from this kind of, what I would say, this fragmented linear BIM process to more of this circular, connected process. And the way we're going to do that, okay, is, and I think our obligation as a technology company is to provide the data, the technology to allow you to implement that. So at Autodesk, we've already started the journey of moving away from building these monolithic desktop products to being a data and platform company, okay? And so what does that really mean? Well, if you're using Autodesk cloud solutions today, whether you realize it or not, you're actually on that journey. So we launched, it used to be called Forge, now we've renamed it. We love to rename products at Autodesk, unfortunately. But it's now called Autodesk Platform Services, but I'm going to call it Forge because I think it's a cooler name. But what Forge is essentially is our platform as a service. It sits on top of AWS cloud infrastructure, and the way we build all our next generation solutions are built on top of this platform with different types of APIs and web services. They're the same services we make available to our clients, even to our competitors, where they can build their own applications on top of this platform. Okay, so today what that platform does, it already connects to different types of vendor IP, different types of file formats. We have different types of APIs and web services that you can take and assemble to build different applications. And there's already an ecosystem of 4,000 companies that are using it. Okay, so that's the same platform that allows you to do things like data integration. So at the top, what you'll see is you've got Rhino on the right-hand side doing a building facade, using Forge to seamlessly update Revit on the left-hand side. Okay, so two different applications operating at the same time, connected through Forge to do real-time synchronization. Okay, the bottom is a Tekla example. Okay, you've got a Tekla structural model, you've got a Revit model, different people using different applications, connecting and updating and synchronizing at the same time. We have people building project dashboards. I want to build a project dashboard that connects Autodesk solutions to SAP or some other kind of data environment and build a project dashboard. You can do that today. We even have people building digital twins, and the word digital twin can mean something different to different people, but we already have people building a digital representation of the physical world and then connecting that to different types of data systems already. People have been doing this for 5 years, and a great example is that same project, E39 or E59, I think it's E39, in that Norconsult was building. They actually built a digital twin 5 years ago using Forge. They were aggregating data from Villanova, Autodesk, other vendor applications, assembling it in a way to build a digital twin and then communicating with their client, Norway New Roads. Okay, so this is already happening, okay? And that same platform, Forge, or Autodesk Platform Services, Autodesk is delivering its own next generation digital twin platform called Tandem. And what Tandem allows you to do is consume Revit and IFC and build a digital representation of a physical asset and manage all that geometry and all that metadata. And that becomes your situational awareness tool where you can then connect that to real-time operational systems. So this is all, everything I'm telling you has been part of, sometimes I know it may seem there's no method, it's chaos at Autodesk, but there is actually method to the madness. And we're trying to bring our customers on this journey to help them drive innovation in the industry. But, we're not done. At Autodesk University, you would have heard the term announced, Forma. So Forma is really just a brand at Autodesk that represents our next generation industry cloud. That is the foundation of what I talked about, us moving from being a product company to a data and platform company. Everything we build in Forma is actually built in the same environment that I just shared with you that's available today. So what is Forma? Forma is Autodesk's AEC data model and platform in the cloud. So when you create content in a product like Revit today, it's actually going to be populating and creating a data model in the cloud. So instead of managing files, which is what we do today, we manage a bunch of files in a common data environment and connect these files together. We're going to be managing individual objects that are assembled in a coordinated way, not just in a file, but in kind of a database environment. So think of your Revit model of a building as an example, where you have floors and doors and columns. Okay, all of those are assembled into a Revit file within a file. Imagine turning that file inside out, and now what I'm managing is doors and floors, next to roads and highways and buildings and tunnels and so forth that are all connected. And the APIs that we will build to build our next-gen products are the same APIs that you can go and actually interact with that individual object, not that individual file. So that you're going to start hearing from us the term building granular data environments, not file-based environments. So files at some point are going to go away. not anytime soon. You're still going to create a file today, but that data within that file is going to be essentially populating this granular data environment in the cloud. So if you think about why are we doing that? We're doing that in order to help the industry break down some of the artificial silos that exist today. Now, some of those silos are contractual silos, and I think as the industry continues to evolve between delivering design, bid, build to design, build, and public-private partnerships and alliances, some of those will go away over time. But what we're really trying to drive is frictionless connectivity, the ability to collaborate not at a file level, but at an object level, the ability to audit everything that happens in the project. And in order to get the benefits of AI and machine learning, you have to have an underlying data environment, a rich data environment. And that data environment isn't just going to be the Autodesk data environment, it's going to be connected to other data environments, which is what I described and I called federated data environments. So if we expose all the data, then we can begin to get the benefits of things like AI and machine learning. So that's the shift that you're going to see, I believe, or we certainly believe at Autodesk over the next several years. So in closing, what I wanted to say is we're focused on building the BIM of the future with the industry cloud called Forma. If you're an Autodesk customer today, you're on that journey, whether you realize it or not. One of the key value propositions is to unlock that data and make it available to our clients and to our customers. But at the same time, this is going to be, and I'm going to use the word, an evolution, not a revolution. So if you're using Autodesk technology, be rest assured that we're going to pull you along with us at whatever pace that you need. And I think this is one of the key things that certainly we have to contribute to the industry to help it digitally or continually digitally transform and solve some of the problems that I know many of you are very passionate about and are here today meeting with your peers. So on that note, I want to thank you for your time, and I appreciate everything that you do to change the industry. Thank you.
Thank you so much, Theo. Really interesting first keynote speech of the day. Great to hear all about the different technologies and how things are moving forward. As a consumer and a flyer, I want to know, when will it be common for me to show up at smart airports?
Well, I would argue there's some airports that are pretty smart today. I think what you're starting to see in airports in particular is a lot of the owners, and the one key differentiator I think with an airport is they generate revenue. So they're highly incentive to optimize the way that asset works. And they want to actually, I'll give you an example. I know I don't sound like it, but I live in Colorado. And I think Colorado now is the third largest airport in the world in moving people. And they've been on this journey for, I would say, a decade of building kind of their digital environment, connecting BIM and GIS, optimizing the way they operate the airport, analyzing a lot of their carbon footprint. And in fact, I was in Boston this week, and the lady that runs the capital program has a goal of being net zero by 2031. So I think it's kind of happening in front of us. We just need to take it from airports to everywhere else, hopefully.
Yeah, exactly, and share more information about it. We've got a poll for you. I feel like we should have maybe done this poll before your speech because you've made such a strong argument. But audiences, get your QR codes at the ready, and those of you online, get ready to tap in. The question is BIM outdated, or should we continue to invest? But honest answers here. And we'll look at the results in just a few moments. Hopefully everyone's got the hang of how to use the technology so far. And Theo will be sticking around for our next panel discussion. So,
do I get to vote as well?
If you've got your phone in your pocket, or we can add you to the result. But it's looking pretty strong here. But yeah, Theo will be sticking around for the panel discussion, so you can also send in your questions to him on this topic as well. The scores are switching around a little bit. At the moment, it's looking like, so if 1 is outdated and 6 is continue to invest, the majority of you think continue to invest, 53%, but some a little bit more unsure about how much the focus should be on BIM. Are you surprised by those results?
No, I mean, I think it's heavily. I mean, I don't think a lot of traditional methods are going to go away. It's how we incorporate them into the BIM process. But I think if I look at your chart here, it's still overwhelmingly to the right. So I think that that's a good thing.
Yeah, I think that might have had something to do with your speech as well. All right, well, let's give a huge round of applause to Theo. We'll see him later in the panel. Thank you very much.
Thank you.